Um, Hello, my dear online students. Um, my name is Dr. Lee. I will be teaching you mechanical engineering mathematics this semester. I'm sorry, and um, it's a broad area, engineering mathematics. After discussing with the other teachers, we decided to focus on linear algebra. Um, I just had a chat with other campus students. They are in this classroom. They are in this classroom. And say hi. Say hi, everybody. Hello. Okay, good. Um, I I'm sorry for you guys that cannot be here with us. Um, I hope the pandemic can get over soon with the vaccine coming out. That again, my name is Dr. Lee, and I finished my PhD degree in United States. Um, my hometown is in Kunming. I was born and grew up in here in Kunming, and I went to United States to get my PhD degree, and then I came back because my parents were old and sick, and so I came back and teaching in this university. I'm very glad to teach your everybody here and you. I I hope the online can work well. I hope. Um, mm, uh, this is I introduced the students my brother's name. I do not want to waste your video time, so we move on. So how's the textbook what the previous semester, last semester for online students? Send the PDF to them. I see. Okay. And for my class, for you guys need some ruler. You guys need some ruler. Today is the first class. Today is the first class. Um, I, but the next week, bring some kind of ruler. Today you may use your cell phone to draw. You need a notebook. Please bring a notebook. Please bring a notebook. Notebook. Okay. It's better have a better notebook, not yes. It's better having some notebook. Uh, and for online students too, try to. I want you to take notes of my teaching because um, I will teach in my style. I will teach in my style, not in the textbook. Anyway, for online students, you don't have this. I look, this is it's a little over. It's a little beyond our. Um, um, I will teach in my style. You need to take notes. And well, as always, we do the homework in class. In class, we do the homework in class. So if you have any difficulties to solve the problems, then we can do it. We can solve it in the classroom. In the classroom. After you go back, you may, if you cannot do it, then you cannot do it. Um, so we do it together in the classroom. You do it on your notebook, okay? Your notebook is for taking notes and do the homework. Do the homework. And this is, I consider the good news. All the homework will be done in the classroom. In the classroom. And for online, is you may feel for a period, I'm not teaching anything because I give time to students to do it in the classroom, 5 minutes, 10 minutes. I don't know. Maybe we pause because I don't want to, for 5 or 10 minutes, not recording anything. Um, okay. I hope you guys understand my English. Is okay? Yes. More or less. Pretty good. 谢谢，谢谢。Um, mm, that's about all I want to say. That's about all I want to say. Um, for the final exam for online students, right now I don't know how to do the final exam for you in your home country. But for online student, for here, for campus students, the final exam will be all out of the questions from your notebook. Will be all out of your notebook. And that's a lot, I can tell you. Your notebook will gradually get more and more stuff. Um, your notebook will be your treasure. Will be your treasure. Even after 1 year or 2 years or maybe 5 years from now, when you browse through your notebook, you can say, oh, wow, this is what I did in Dr. Lee's class. Kind of brings some memory back. Brings some memory back. Try to do good notes. Try to do the solve problems on your notebook for online, for students here, all together. All together. And don't trash your notebook after the class. It's a, it's a kind of valuable. It's a kind of valuable, regardless how you did in my class. Um, okay, and for you guys, campus students, one thing is that uh, please be on time. Please be on time. Okay. Um, um, I intend to make my class be fun. I intended to make my class be fun. I don't want to be um, mean. I don't want to be mean to you guys. Um, but if you late and my experience, if a student be late, he will always be late. It's a kind of a habit. It's very hard to, if he is late, every time he will be late. And uh, it's a lot of interruption to my teaching. It's, I have students always 10 minutes or 15 minutes late. And in that classroom, and that door is over here. It's not like here. Here they is a little bit okay. If you are late, you kind of came in. Nobody noticed. And the students, every after class starts 10 minutes or 15 minutes, sometimes 20 minutes, and he just opened the door, came in, and it was recording, and all the students, it's very interrupted. It's very interrupted. Um, um, so please be on time, okay? If you have some urgency, be late for one time or couple times. That's okay. I understand, but don't be consistently interrupting my teaching. It's uh, it's just annoying. It's just annoying. Um, right. I think we can stop here for then we take a break. Then we stop. Okay, we start. And again, I don't know which teacher choose this. It's not appropriate. It's not appropriate that I will try to get contact with the teacher. Um, for today, um, you just take notes and listen, okay? Um, the Today we will talk about vector. Vector is a very important concept. A very important concept. And you can just listen to my story, you know. After writing this word, I will give you, I will talk to some ancient story before to get to vector. Um, our human knowledge has always been gradually gets more and more advanced. Okay. In the beginning, we only have a natural number. You don't need to. You don't need to. You just listen. I write it down because I'm afraid my English confuse you. Natural number. What is the natural number? 1, 2, 3. Uh, the reason we have a natural number because when we see the world, we see 1 tree, 2 tree, 3 tree. We see one person, 2 people, 3 people, 4 people, 5 people, right? So we have the natural number. For counting, right, it's easy. Digit. 1, 2, 3, 4, 5. Then later, and a person, a genius, came to think, oh, we should add one more number. We should add one more number. What number to add? Zero. I said, what? What's this? What's this? And he said, that genius say this is zero. What means zero? And that genius say zero means nothing. Nothing is zero. For example, there are 14 people in this room. Okay? There are 0 people in that room. Can you believe it? For example, say how much money in my pocket? Say I have 14 yuan, okay? Another person say, you ask another person, how much money you have? Say, yes, I have. I have. How much? 0. I cannot understand. This is crazy. There is a 0 elephant in this room. Mathematically, that is correct. Right? How many elephants in this room? 0. 0. And oh, okay, 1 elephant. How many tigers in this room?
Maybe 14.
14. Giraffe. How about giraffe? Oh, that's 1.
And one donkey.
Some students, I'm sure, are in Africa right now, and there's lions outside in the window. They can show you. 25 lions just outside my window, right? Then we quit. We all moved to Africa. So that genius is 0. Wow. How many eggs in this basket? In the beginning, there are 5 eggs, and you eat 1. How many left? 4. You eat 1, 3 eggs in this basket. You eat another 1. You eat another 1. Then you eat another 1. How many?
0.
Yeah, 0. There is 0 eggs. English. There is 0 eggs in this basket. In this basket. This is completely correct. 0 eggs. Right now, nobody challenged you. Right now, nobody challenged you. But at that time, we can understand there are 2 eggs, okay? There are 2 eggs, okay? We cannot understand there's 0 eggs. 0 has the same status as 1, 2, and 3, 4, 5, 6, 7, 8, 9. That was that genius did to us. Because that genius, then this is 1 everybody knows, right? Because that genius did his contribution. Now we have this. Now we have this. Now we have because this zero, I should give a special color because it was so great. Without it, because this zero, beautiful zero, we can, with just 1, 2, 3, 4, 4, 5, 6, 8, 9, with the 9 symbols, just 9 symbols, we can express any number you want. We can express any number you want. Even though how many kilometers from the Earth to the moon, we can do it because of zero. Because they can change your position by padding, by adding one, this become 10, add another 2 become 1,000. If you have more money, I can add a couple more in your bank account. In your bank account. Okay? If you have more money, I can keep adding the zero. This is a big revolution. And this one is an Indian. That genius is an Indian guy. And they have a temple in the Indian to celebrate. To celebrate. And I saw it on the video. And there's a big this thing on the floor. They built a temple to celebrate. And they say that's the first zero in the world on the floor. That's the first zero. Because this thing, the human mathematics, dramatically, a big leap. And when you teach kids, it's very easy to teach what is one candy. See, this is one. Oh, this is 3 candies. Yeah. It's hard to teach 0 candies. 0 candies. 0 candies. Okay, this is one revolution. I will, after several revolutions, we will come here. That's the reason I'm telling this story, which is a history and is a mathematics revolution in the history. After several revolutions, we will come here. Okay, be patient a little bit. Okay, so far so good. Then later, another genius in Greece. This time is a Greek. And this is 1, this is 2, this is 3, right? And he said, well, we should have 1.5 fraction. Wow! What do you mean? There's 1 people, 1 person, 2 people. What do you mean 1.5 people? We have 1 cow, 2 cows, 3 cows. What do you mean 2.5 cows? Are you crazy? The people cannot accept it. And this is a true story. Everything I'm telling are true. Okay? And the public got mad at him. They think he got some evil spirit into his mind. So they threw him into the ocean and get him killed. And you can see that sometimes these mathematicians are great people. They sacrifice their life. Today, we right? We cannot do it without fraction. We cannot do it without fraction. A quarter, we want a quarter something. For example, half kilogram, right? Half kilograms is something. A quarter kilograms is something. When you go to buy a pizza, yeah, you can say I want to half, or you can say I want to 3/4. So, right? Pizza. You want 3/2, or you want to say I want just 1/4. Anyway, you are not fraction are not new to you guys. So this is another revolution. Another revolution. Then, what's next revolution? There are several revolutions. These are number systems. I'm just talking about the math, the number systems. There are many, many revolutions in mathematics. I myself cannot even understand it. But today I'm just talking about the number systems. From the natural number and the zero and the fraction then came negative number. Negative number. Right? So, you know, you can understand the two, but I think negative, for me, I've learned negative in middle school. I think maybe these days they're teaching kids in elementary school, what's this? Yeah, -2. But for kids, it's still a little bit challenging. Yeah, they can understand the 2, but the -2, what's that? What's that? I can understand the 2 candies. What means -2 candies? That means you own 2 candies. You own somebody 2 candies. If somebody gives you 2 candies, if right now this is how many candies you have, that means you own somebody 2 candies. Yeah. If this is the temperature, let's say 2 degrees, and this is -2 degrees, this means below 0. This means below 0. This means above 0. And so for the numbers now, this is bad. Okay, 0. And now we have this stuff, okay? 1, 2, 3, 4, 1, 2, 3. And here now, the other one, -1, -2, minus 3. And others, I didn't do it like 1.2, 1.35, 2.4. Everything is here. Is on this number line. And another revolution, I don't want to get into too much, is irrational number. For example, like this. Goes on forever. Never ends. This is a crazy to some people. Like a pi. This is a crazy. For some people, wow, never ends. So what's here? Can you draw? Can you draw the here? Can you draw it? You can draw. This is a 1, okay? You put your ruler, 1 and the vertical. Draw. This is also 1. Okay? This is a 1. This is a 1. What's here? What's here?
Triangle.
What's the length?
1, 2.
The length here is that number. Is this the number?
Yes.
Because Pythagorean theorem. I don't know, I can spell it. Pythagorean, something like that. Theorem. Okay? Pythagorean theorem. That means if it's a vertical triangle. C, this is A, this is B. What is that? C squared, right. A squared plus B squared equal to C squared. Okay? If this is a 1, then C is square root 2. Square root 2. Okay? It's not 2. If it's a 2, then that becomes 4. Okay? It's a square root 2. So after you square it, becomes a 2. And then 1 squared is a 1. B squared is a 1. 1 plus 1 is a 2. Equal to 2. So here is a square root 2. And you just use your, how to say that in English word? Slip? You guys are doing it for life. Compass. Okay. So you draw it, and so here is the length of this irrational. Is this irrational? Okay. 1.4. 1.414. Never ends. So this is another revolution. Irrational number. I erased. These are, of course, are rational number. 1.4 is a rational number. 2.3 is a rational number. Okay, history. Okay, all these are revolution. When the revolution just happens, you may feel not used to it. You may feel, what? This is so crazy. Why we need that? See? And after you get used to it, you will see Yes, we need it. It's very, very important. Fraction. Can we live without fraction? No. Can we live without zero? No. Can we live without negative numbers? No. So in the beginning, you feel that's crazy, okay? But later, you find it's very important. It's very important. And here comes the revolution I want to teach for today and for next for a few times. This is another revolution. This is another revolution. And in the beginning, you may feel strange. You may feel strange. Why now? Why? Yeah. We always feel strange for new ideas. We always feel strange for new ideas. So, what is a vector after all this? So, what is a vector? Vector is another kind of number. It's an advanced number. Um, so we are doing okay with all these numbers. We don't need we don't need new stuff. No, we are not doing okay with all this. These are not enough for us. Um, if this is a yeast, if this is a yeast, is this? Is this?
No, ENA.
If this is then this is a west. Then this is a west. Okay. If say I moved 3 kilometers, by this you know I traveled facing the east 3 kilometers. If another person say he traveled -1 kilometer, then you know he traveled west. Um, for up and down, two. Okay. If you are a pilot, and you got a direction from the center, say change your height by +5 kilometers. Then you know what you are doing. You are moving up. If let's say change your height by -3 kilometers, you know what you are doing. Right. Yes. Now the thing is not enough. If the center or your boss, if we just tell you the +3 kilometers, you move. If it's a -1 kilometer, you move that. But if we want you move, but if we want you move this direction, want you move this direction, right? Then what do we say? Uh, all these are northeast. This is northeast too. This is let's say here come down is 2, okay? And let's say here is 1, okay? And let's say this one come down is 1. Here is 2. These and these are completely different things, right? Um, okay, let's say you're on the Pacific Ocean. You're on the Pacific Ocean. You are the captain of a boat. You are captain of a boat. And and the center say there's a storm coming. Please move that so and so direction to get away the storm. They want to give you or you are telling the center. The center was asking, report. Which direction are you going? Which direction are you going? Now, you just say, I'm heading east. It's not enough. You are going one of these directions. Okay? This is now we need a vector. We need a vector. The vector is advanced. Advanced. For example, if for this is a vector. This is another vector. This is a vector, okay? Vector. This is another vector. Then the length, this one and this one are the same. Because the Pythagorean I just erased. This is 2, this is 1. For this director, this is 2, this is 1. So for the hypotenuse, is the same. This one and this one is the same. Yeah, the long side. The long side is the same. But there are 2 different vectors. Because the direction is different. Because the direction is different. It's just like 3 kilometers and minus 3 kilometers. Are they the same? No, even though their length, the length is the same, but this is different. Okay? If you write you guys are mechanical engineering, for the cars or for the rocket, never treat them as equal, okay? If that, our rocket will explode. I'm serious. I'm serious. I love to tell stories. True story. Okay. I don't want to say this again. Everything I'm telling is true. Okay. This is really true. And U.S. and the European are cooperating to shoot a rocket. And in U.S., it's very strange. They don't use a kilometer. They don't use a kilometer. They use a mile in U.S. They use a mile. How many miles? Everywhere use a kilometer. 1 mile is 1.6 some kilometers. And people, we use a centimeter, right? Millimeter. In US, and we use meter, right? How many meters? No, they don't use it. They use a foot. They use inch. They use inch. Even for the Olympic Games, when I was in US watching the Olympic Games for the high jump, I know because about 20 years ago, the world record was Chinese. At that time, he was doing 2.40 meters. The world record, and it was 2.40 meters. Now he's already retired. That when I was watching the Olympic Games high jump in US, they don't use meters. The TV, they don't report in meters. They say, right now they are jumping. This is some foot. I have no idea. At that moment, the athletics is working on 2.40 or 2.41 or 2.42 meters. I have no idea. The TV is reporting they're working on their jump on how many feet, how many inches. And so for that rocket crash, and that's a number 2. And European scientists always think this is 2 centimeters. 2 centimeters. And the American scientists think this is 2 inches. So the rocket exploded. Then after that, they tracked. So what's wrong? And they found that because of misunderstanding. It's very strange. US, they use miles. Inch. This is called a British system.
Yeah.
But even the England, even Canada, they use this. This is called a metric system. Even England, they don't use this anymore. US use it. It's very strange. Okay. These and these are different. Okay. I guess nobody will be against everyone. However, these and these are also different. Even though they are the same length, they are different. And they are different because their direction is different. So the vector is an advanced number. It has the length. And it also has a direction. For example, let's say another one. Let me draw another one. the red one and this one has the same direction. However, the length, the red one is a double of this one.
Yes.
So this and this are also different.
Exactly.
Okay. So the vector, um, the symbol for vector is, for example, normally we say this, we use a equal to 3, right? B equal to 2.5. These are, for vectors, we have these.
Yeah. Exactly.
We have a head.
Yes.
Okay. For printing, they just printed a daughter. But for handwriting, there's this means has a, when you see this, you know this is a vector. Okay. When you see that, you know this is just a number, a value. Okay, a value. We don't know what is the number could be. But you know this has a direction in it.
So it's literal.
Okay. Then A plus B. What's the result? 5.5. Okay. Now next, I just after we take a break, we will do adding. We will do adding. Vector A plus vector B. Vector A minus vector B. How to do it? That will be advanced. Will be different. We take a break now. Okay. Yes. Yes. Stop. Okay. We continue with the vector. Um, that we said vector is an advanced form of number. It's an advanced form of number. It is not just with the value. Normally, when number has a value, like 3, 2.5, that's a value. But this kind of system doesn't tell us which direction is going. Which direction is going? 3, which direction could be going anywhere. And the vector, it has the attribute. It tells not just the value, it also tells the direction. It also tells the direction. For example, you simply say going up and going down are very different story, right? And also going this way and going this way are also different, like that. They are also different. So for the vector A, for this one, what is the value for the vector A? For this one, the red one, it means going to this side 1, okay? And going up 2. This is the vector. Is this vector? Okay. And many times to make life easier, this and this are the same thing. It's just drawing the bracket. It's need a little bit more stroke. And for this is okay. And this is a vector. And for textbook, because vertically they are taking too much space. So they want to print, so this is empty, this is empty, too much space. They prefer to horizontally, but these and these are different. These and these are different. So that means this two is move on to the second line. This means if without this, this is just one line. That's a different story. That's a different story. This with this semicolon. These and these are the same. For printing, this is because each line they can write more. This is taking too many rows. You are occupying for printing this. You are occupying maybe 3 lines. Okay, then so for the book, but in real life, I think everybody prefer vertical. It's visually is more clear. This is better. Okay. It's not just right now. It's a simple vector. Right now it's a simple vector. It could be many. Just an example. Okay. 7, 4. 4 rows. This is a vector. Is not a vector. Okay. Now, right now we are just start. We use easy vector. This is a 2-dimension. This is a 2-dimension. It's a flat. Okay. This is a 4-dimension. Later. So just. Okay. This is a vector A. And what is a vector B? Can you tell me what is vector B? What is vector B? Okay, now on your textbook, on your notebook, draw this, do it. And you don't have a ruler, or you might use a cell phone, or just a hand drawing. The marker, try to make it even, okay? Try your best. Maybe use your finger. 1, 2, 3, 4. Draw it, okay? Draw vector A, draw vector B, and you tell me what is the value for vector B. This is hard for online. Maybe we should stop because. Yeah. So the vector B is 2, 1. Horizontally by 2. We always the first horizontal, then vertical. Okay. 2, 1. Okay. Everybody got it? Now let's do it doing what we did in elementary school. In elementary school, 2 plus 3. Okay, your teacher did. Now we are doing vector A plus vector B. I'm teaching you right now. I do not ask you, but I will give you another question for you to practice. This is a vector A, okay? This is a vector B. The way to do it is this one and this one. Okay? needless to say, the result is the third vector. Okay, the result is the third vector. Now the question is only what are the numbers. Okay, the way to do it is this one plus this one, which is 3. Okay, and this one plus this one accidentally is also 3. So if it says this is vector C, that means vector C equal to vector A plus vector B. Then I'm always looking stuff here. Vector C is the summary. We will do subtraction later, but we do the summary first, like we did in elementary school. For multiplication, hold on the patient. Okay, we will do multiplication. It's a very, very different. Okay, it's not like 2 plus 3, 2 times 3 is 6. No, it's much more, more advanced, more complex. For the summary, okay, this is the way to do it. There are 2 ways to do the summary, vector summary. I should write here. The summary, addition, or we say addition. Addition. There are 2 ways to do it. There are 2 ways to do it. One way is I showed you just add the numbers. Okay. There are 2 ways. I hope online students you do this okay. Another way to do, the result is a 3 3. Okay, and can you draw the vector? This vector, draw it on the here. Can you draw it? Draw vector C. Draw it now. Do it now. We need to pause. Okay, I hope online students also did this. Draw the vector. Draw the vector on the here. So what is the 3 3? So you travel 1 2 3, and 1 2 3. Okay, you find it, and with the ruler, 1 2 3 and 1 2 3. So that's here. That's here. Okay. And if could use a different. This one looks. Do not know. So this is a vector C. Vector C. It means travel the 3 in this direction, and the 3 goes up. Okay, And another way, do not do this directly, do it in geometry way, is um, this, okay? Um, um, I don't want to mess up that one, so I will draw another one. I will draw another one. Um, we will in this class we will have a lot of drawing, so we do need to get a ruler. Okay, next time. So um, um, you have noticed for vector A plus vector B, if I change the order, if it's a vector B plus vector A is the same, okay? Is the same. This is a consistent. This is a consistent with our elementary school. 2 plus 3 is the same as the 3 plus 2. This is a consistent, okay? I pointed out, but for vector, do not expect everything is a consistent with elementary school stuff, okay? For consistent part, I will point out. For different, of course, I need to point out, yes. So, vector A plus vector B and vector B plus vector A, they are the same. So let's do, I need this space. Vector A is 1, 2, okay? 1, 2 here, okay? I'm doing the second way, geometry. So this is a vector A. What is the vector B? Vector B is a 2, 1. 2, 1. Okay. This plus this. How to do this plus this? Draw a parallelograms. Draw parallelograms. How to draw parallelograms? So this one is a parallel to here. You can do it with dotted line. Okay, and here parallel. Okay. Do you see everybody said? This one and this one form a parallelogram. You know parallelogram?
Yes.
For parallelograms, this side and this side are parallel. This side and this side are parallel. Okay? So for when you need to add two vectors, bring them ending point together. Draw a parallelogram. And from here to here, that is C. From here to here, that is C. So this is for doing addition, geometry way. For doing addition, geometry way. This one looks like is a 3. Here is a 3. This one is a 3, 3. This one is a 3, 3. It's amazing. It's the same as this. And that's the reason why you do this and I do this, they are equal. That's the reason. And I don't teach you that why they are equal. If you want, you can think about it yourself, why they are equal. Because in that direction, let's say this is A, right? Vector A, and the change, the further change, the 2 adds on top of that. So this part the shifting over there, shifting on that direction is a 2. And this is the shifting on this. And the shifting on the top is a 1. And that is this part is over there. Geometry and algebra, they are 2 fingers pointing at the same moon. You say, that is the moon, and you come here. Oh, that is moon. The 2 fingers are pointing to the same moon. Actually, they are talking about the same thing. They are talking about the same thing. And you are required to be able to do both. You maybe feel, oh, this is easy, I just do it. Looks easy, but this is more meaningful because the vector has a direction. Is you can say is a geometry, is a geometry thing. It's a geometry thing. I want you to keep the geometry in mind. I want you to keep geometry in mind. Okay, now we do another vector. Let's say vector D. Let's say vector D. And let's say vector D is a 2, 4. No. Vector D is a 2, 3. I want you to do it both. Vector A plus vector D. Do it on your notebook. One way is the algebra way. Another way is by drawing the parallelograms. Drawing parallelograms. Okay? Okay, can pause. 谢谢. So what is the result? Vector A plus vector D. First way, okay? First way.
3.
And what is the vector A?
1,
2. And what is the vector D? And 2, 3. And the number, okay, I just read them. Is that outside the recording? Is that the video? Can you see it?
Yes, pretty visible. Like
So the result is 1 plus 2.
3.
There's a 3. 2 plus 3, 5. So this is the two adding. The adding, okay? Everybody got it?
Yes.
Good. And this is the algebra way. Geometry way, where to draw it? Okay, geometry way, the two are a little crowded. A little crowded. 1, 2. This is A, okay? This is the vector A. And the vector D is what? Can you draw it? 2, 1, 2, 3. Okay. Wow. 2, 3. It's too crowded. Sorry. You have to draw a very narrow parallelogram. If you cannot do it, that's okay. I give you I apologize. I give you a different one. Okay. Let's say the vector E is minus 1 and 2. Minus 1 and 2. Vector E is minus 1 and 2. Can you draw it here? Can you draw it? Where is the vector E? Can you draw it? Where? Is this a direction or
left?
Right. Left one, minus 1
1
and 2. So it's here and the triple 1, 2. Okay. That's here. Okay. So this is a vector E. Okay. Now I want you to do it in 2 ways. I want you to do it in 2 ways. Vector E plus vector B. Vector E plus vector B. I want you this vector plus this vector. Do it in geometry way and in algebra way. Now this time you can draw a beautiful parallelogram. These two. And you can check. You can check in algebra way. You got is that the same as your drawing after you get the parallelograms? Okay. Pause. And okay, what is the vector E plus vector B.
1 and 3.
Okay, vector E is a minus 1 and a 2. And the vector B is a 2, 1. And the result in algebra way, this one is 1. This one is 3. Okay, good. How to draw it? How to do it? How to do it? E plus B. E plus B. Okay. Draw a parallelogram. Draw a parallelogram. Okay. And this one. So. Okay. So this, do you see parallelograms? You see? This one is parallel to here. This one is parallel to here. Okay? A little bit messy. Yeah. So the other point from here to here, that is the way to do it in geometry. Okay? After drawing, you can measure this one, and it's 1 and 3.
Yes.
And this one. Life is good. Okay? So there are two ways to do the addition. Um, uh, now we need to do the scaling. The scaling is a little bit like multiplication, but it's not that much. For example, this is a vector A, but 2A is what? So it's 2 times 1, 2. 2 times this vector is a scalar. This is a simple number. We call it a scalar. Okay. Scalar. It means it's just a number. It's not a vector in opposite. So it's not a vector times a vector. We have to wait that almost to the second half of a semester. It's complicated. A vector A times a vector B is complicated. Have to almost to the second half semester. But for a scalar, a 2 times or maybe 3 or maybe 5 times a vector, that is simple. What's this result? This result means do it twice, okay? If this is vector A, okay, from here to here, this means do it twice. Right?
Yeah.
Okay? So what's the result? this is a scalar.
Yes.
Scaling. And for drawing, I erased the vector A. Let's do it the vector B, since B is over there. And let's practice it. And let's say 3B. What is a 3B? What is a 3B? 3, what is B? 2, 1. And I use here. So it's 6, 3. This is a algebra way, okay? Do it. So this is a vector B. So extended 3 times. This is 1 times or 3 times, okay? 1 times, 2 times, 3 times. So the result vector, the result is another vector, okay? So the result vector is from here to here. And I can draw another one. Like so the result, let's say the result is f. I give it f, okay? F is a 3b, and f is a 6, 3. This is the vector f. And you count it, yeah, that's a 6. And that's a 3, okay, if I draw it perfectly. So this one is indeed 6, 3. Are you following me? Scaling, okay. Now there's a very special case. -1, let's say, vector G is -1 C. This is a very special case. This means, let's say the original vector B is like this, from here to here, okay? -1 means what? It's opposite. It's opposite direction. We can do it in number -1. What is B? 2, 1. It's over here, okay? I look at. Or you want to look at that. It's the same thing, okay? 2 fingers pointing at the same moon. 2, 1. So what's the result? -2, -1. Where is the -2, -1 here? Okay. Where is the minus? So is over there?
No.
Right. It's the opposite.
Downward.
Yeah. Don't ask me in the final exam, okay? There was one student in the final exam was asking, teacher, -2. I said, I cannot tell you. You can ask me now. Don't do it in the final exam. So it's a -2 going backward, okay? And it's a -1 down, not up.
Yes.
So it's here, okay? -2. Okay, this is vector G. And you can tell is just flipping vector B over. This is vector B, flipping it. Okay. Now, what is the vector? This is vector A. Now you should know how to do it. Vector A minus vector B. This, let me erase. Let me move over here. Vector A minus vector B is the same as plus. Okay? Like in elementary school, 3 minus 2 is equal to 3 plus minus 2. Even though it's a subtraction, but you are doing it in a summation, in an addition way. Just change this. Yeah. Okay. It's a subtraction, but you are doing in addition way. Okay. Now I write it here. Subtraction. And write it on your notebook. This is our today's content. Addition, scaling, subtraction. This is two ways, okay? This is two ways. Both will show up in the final exam. Both will show up. Addition. The geometry way, I'm more worried about geometry way. I know you guys feel it's more natural to do it just adding numbers. Write it down on your, okay, this is our today's, so the vector A minus vector B is the same thing as the vector A plus. And so what is A plus, this one is vector G. Okay, you can do it in two ways. Okay, you can do this in two ways. Let me make it red color. You can do it in two ways. So one way is vector A is 1, 2. Another way is vector G minus 2 minus 1. Okay? Is what's the result? What's the result? One, this one, minus 1, okay? This one, 1. Another way to do it in geometry do it in geometry. It's this one and this one. This one and this one. How to do it? How to draw it a parallelogram? How to draw it in parallelograms? You do it. Okay? Pause. Okay, 谢谢. It's a lot of work. Um, did you got it? Did you got it? This one by plotting, not just that's easy. Well, but we need to learn. This is why we take the pain to learn. Okay. The the vector, the strength of vector is a direction. Is a direction. Is a geometry. Is a geometry. So, do you need me to? Do you need me to draw this, solving this by plotting? Do you need me? So vector A, okay, I do it. Vector B, okay? Vector B and minus vector B is G, okay? Is flipping it.
Yeah.
And the vector A is 1, 2. And where is the 1, 2? Where is the 1, 2? Is 1, 2, okay? So, yeah, that's vector A. Okay? This is the vector A. And now we want to do A plus G. We want to do A plus G. G, okay? We draw a parallelogram. So here, we push. Okay? And here, ready? 1, 2, 3. Okay. Thank you. More or less. Okay. So, so this is a parallelogram. Okay. This one is a parallel to here. Okay. This one is a parallel to here. Okay. And so the opposite point is this plus this, and which is this minus this. Which is a minus 1, well, minus 1 and a plus 1. Okay? You see it? Now, take home the word homework is a b minus a. Yeah, you do it on your notebook. Okay? And you do it on your notebook. Um, I think b minus a. Vector b minus a. And this is the first question. The second question is scaling. The first question is b minus a. The second one is after you got it, scaled. Scale. Okay, scaling. Okay, and that's enough. You make this.